In this video, we are going to solve D1 7th edition exercise 1A, and question number 1 is determine whether each of the following is a prime or a composite number. Now in part A, they have given us 87. 87 is a composite number because a composite number is a number which have more than two factors. So 87 has three factors, that is 1 and 87 and then 3 as well. Because when you will add 8 and 7, 8 plus 7 is 15, and when you will add the digits of 87 and you get 15, now 15 is divisible by 3. So this 87 can be divided by 3 as well. So we have got 3 factors of 87. So now that's why it is a composite number. Then we have 67. Now 67 is a prime number because factors of 67 are 1 and 67 only. So a number having only two factors is basically a prime number. Then we have got 73. Now 73 is also a prime number because factors of 73 are 1 and 73 only, and then there is 91 in question number 1 part D. So 91 you can divide it by 7. 7 13 times 91 and 13 1 times 13. So 91 has more than two factors, that's why it is a composite number. In question number 2, they have asked us that find prime factorization of each of the following numbers, leaving your answer in index notation. So this is part 1 of question number 2. So doing prime factorization of 72 and starting from the number which is the smallest prime number here, 2 36 times 72, 2 18 times 36, 2 9 times 18, 3 3 times 9, 3 1 times 3. So you can write 72 as product of its prime factors as 2 into 2, 2 into 3 into 3. Now these are prime product of prime factors of 72. Now in index notation, you simply need to express them in power form. We have got 1 2 3 2's, so when bases are same, there are we have got base 2 here, base 2 here and base 2 here, and the power of 2 here is 1. Then here we have got power 1, here we have got power 1. So when bases are same, you add the powers. So 1 power from here, 1 from here, 1 from here will give you 2 raised to the power 3, while we will be having 3 raised to the power 2 from here. This is index notation. Now prime factorization of 187, you can do prime factorization of 187. The smallest in this case, the 11 is a prime number which can basically divide 187. So 11 17 times 187, and then 17 1 times 17. So 187 can be expressed as a product of its prime factors, like 11 into 17. They both are prime numbers. So we this is the answer in this case, because index notation here you have got only 111 and only 117. So this is the answer for that as well. In part C, we have got 336, and when you will factorize 336 to 168 times 336, to 84 times 168, to 42 times 84, to 21 times 42, 37 times 21, 7 1 times 7. So we can express 336 in index notation as 2 raised to the power 4. From here 1 2 3 4, we have got 4 2's, so that is 2 raised to the power 4. Then we have got 3, and then we have got 7. So this is the answer. In part D, we have to express 630 as a product of its prime factor in index notation. So dividing 630 by 2, starting from 2, using prime numbers. So 315 times 630, then 3 will be used because you cannot divide 315 by 2, so you have to use 105 times 315, then you have to use 5 because we cannot divide this, or you can divide this one. Yes, we can divide this one by 3, so let me make a correction over here. So here you have got your option, you can use 5 as well. Using 5 here, so 5 21 times 105, then 3 7 times 21, and 7 1 times 7. So I have done this one as well. From here you can use 3 as well in place of 5, but the answer will not change. Answer will be the same as this one. So the product of prime factors of 630 in index notation will be 2 from here. Then we have got 3 square, 1 and 1. We have got 2 3s. So 3 square into 5 from here, and then we have got 7. So this is the answer for product of prime factors of 630. In question number 3, we have to find each of the following by prime factorization. You have to find square root of 1764, square root of 576, cube root of 3375, and cube root of 1728. So square root of 1764. Now first of all, do prime factorization of 1764. That is 2 8 times 16. You have got 17 over here, so 1 will be carried to this 6, it will become 16. 2 8 times 16, and 2 2 times 4. Again divide it by 2, because it is possible here to divide it by 2. The last number is an even number. So 2 4 times 8, 2 4 times 8, 2 1 times 2. Now divide it by 3, because it is divisible by 3, because adding the numbers, adding the digits of 441, 4 plus 4 plus 1 is 9, and 9 is divisible by 3, hence using 3 over here you will get 147. Now 7 2 times 14, 7 1 times 7, 7 3 times 21, 3 1 times 3. Now express these prime factors of 1764 in index notation. So 2 and 2 is 2 square, 3 and 3 is 3 square, 7 and 7 is 7 square. Now when you have to take square root, you need to express your numbers, the factors, in square form. Now expressing in square form, and you know that square root and squares are cancelled. So I have cancelled this square root and the squares, that I can do that. So I will be left with 2 into 3 into 7, and that is 42. So square root of 1764 is 42. Next question is to find square root of 576. Now 576 can be factorized as 2 288 times 576, then 2 144 times 288, then 272 times 144, then 236 times 72, then 218 times 36, 29 times 18, 33 times 9, 31 times 3. Now we have got how many 2's? 1 2 3 4 5 6. So 2 raised to the power 6, and we have got 2 3's, that is 3 square. Now taking square root, and as you know that a square root is basically power 1 by 2. So when you will apply your square root on 2 raised to the power 6, you will get 2 raised to the power 3. I can do that over here as well. 2 raised to the power 6 square root mean 2 raised to the power 6 raised to the power 1 by 2. When you will express your square root in this form, you can write your square root as 1 by 2. Now 2 1 times 2, 2 3 times 6. Now you got 2 raised to the power 3 from here after taking square root of 2 raised to the power 6. And square root of 3 square is 3 square, and square root cancelled. And one more thing, this square root applies to 2 raised to the power 6 and 3 square separately. You have to apply the square root on both of them separately. So 2 raised to the power 3 is 8, into 3 is 24. The cube root of 3375, first of all, do prime factorization of 3375. You can start from 3 as well. Anyways, 5 6 times 30, then we have got 37, 5 7 times 35, carry 2 over here, then 5 times 25. Again dividing by 5 you will get 135, again dividing by 5 you will get 27, 3 9 times 27, 3 times 9, and 3 1 times 3. So you got prime factors of 3375. Now express them in index notation. 555 is 5 cube, 333 is 3 cube, and whenever you have to take cube root, it is better to have your factors in cube form, because cube root and cube, they are basically cancelled. Cube root and cubes are cancelled, so 5 and 3 equal to 15 will be the cube root of 3375. Part D, question number 2, exercise 1A is to take cube root of 1728. Do prime factorization of 1728 to 864 times 1728 to 432 times 864 to 216 times 432 to 108 times 216 to 54 times 108 to 27 times 54 39 times 27 33 times 931 times 3. Now you have got how many 2's? 1, 2, 3, 4, 5, 6. 2 raised to the power 6 from here, and then 3 raised to the power 3. Now when you will take cube root of 2 raised to the power 6, you will get 2 raised to the power 2, and when you will take cube root of 3 raised to the power 3, you will get 3. Again I am explaining this process, that the cube root of 2 raised to the power 6 mean 2 raised to the power 6 power 1 by 3. When you will express your this form, this is called radical form, in index form or power form. So cube root is written as 1 over 3. So 3 1 times 3, 3 2 times 6. So you will be left with 2 square, this one. Similarly, applying cube root over 3 cube, so cube root and 3 will be cancelled, the power, you will get 3 over here. 2 square is 4, 4 into 3 is 12. Now, exercise 1A, question number 4 is given that the prime factorization of 9801 is 3 4 into 11 square. Find square root of 9801 without using a calculator. So solving question number 4, exercise 1A, we have been given the product of prime factors of 9801 and they are in index notation. So taking square root, when you will remove this square root, mean you will express it in exponential form. This is exponential form, this is radical form. So in exponential form, square root can be written as 1 by 2. So 4 and 2 will be cancelled and you will get 3 raised to the power 2. While here 2 and 2 will be cancelled, you will get 11. So 3 square is 9 into 11 is 99. In question number 5, exercise 1A, D1, they say that given that prime factors of 21952 is 2 raised to the power 6, 7 raised to the power 3, find cube root of 21952. Now, when you will take cube root of 21952, you will write the factors, prime factors of 21952 in index notation, and taking cube root of both of them. Cube root of 2 raised to the power 6 will be 2 square, because cube root in exponential form is written as 1 by 3. So 3 and 2, 6, 3 and 6 will be cancelled. So you will get 2, 3, 2 times 6. Similarly, when you will take cube root of 7 cube, to remove or to express this cube root in exponential form, it is 1 by 3. Expressing it in exponential form, this 3 and 3 will be cancelled. You will get 7. 2 square is 4. 7 4 times 28. Question number 6 from exercise 1A, and that is estimate the value of each of the following: under root 66, under root 80, cube root 118, cube root 730. So we have to estimate. So under root 66 can be written as under root 64. because 64 is a square number which is near to 66 and 64 is square of 8. So you can express 64 as 8 square and square root is cancelled. So answer will be 8 for part A. In part B, you have to take square root of 80. So you have to look for a square number which is near to 80. Now 81 is nearer to 80 and 81 is a square number, I mean it is a square of 9. So square of 9 is 81. So take square root of 9 square and square root will be cancelled. So your answer will be 9. Now take cube root of 2118. Now we have to express 2118 in the form of a cube number. So basically 2118 can be written as this one over here. You can write 2118 as 2116. The reason is that 2116 can be expressed as 6 cube. So we are looking for a cube number here, mean a number whose cube root is possible. So 218 can be written as 216 and 216 is 6 cube, and taking cube root of 6 cube you will get 6. Similarly 730 cube root of 730, express 730 as 729 because 729 is a cube of 9. So we are expressing each of these numbers to the nearest square number or cube number. So 729 is 9 cube and cube root is cancelled. So your answer here will be 9. Question number 7 from exercise 1AD1. Use calculator to evaluate each of the following, leaving your answer correct to 4 decimal places where necessary. In part A, you have to calculate 7 square minus under root 361 plus 21 cube. So 7 square is 49 minus square root of 361 is 19 using calculator. 21 cube is 9261, and when you will add all of them, in 49 minus 19 plus 9261 will give you 9221. Now in part B, you have to take square root of 555 plus 5 square. So square root of 555 is 23.5584 up to 4 decimal places, plus 5 square is 25, while divided by 2 cube is 8, and cube root of double triple two is 6.0550. So simplifying this one using a calculator, you will get 1.0024 as your answer. The part C of question number 7, exercise 1 is 4 square root of 4 cube plus cube root under square root of 4913. So 4 cube is 64, mean multiply 4 3 times, and cube root of 4913 is 17, and adding them you will get 81, and square root of 81 is 9. Question number 8, exercise 1A D1 is the area of a square photo frame is 250 centimeter square. Find the perimeter of the photo frame, leaving your answer correct to 1 decimal place. So suppose this is a photo frame having an area of 250 centimeter square. Because it is a square photo frame, then all sides must be same. That is, if this is side of length x, then this must be x, this must be x, and this must be x. So area is 250 centimeter square, and you know that area of a square is length multiplied by width. So x into x is x square. So x square is area, and area is 250. So x square is equal to 250. Now take square root of 250. You will get x, the length, that is 15.8. Mean this is 15.8, then this is also 15.8 because this is a square. This is also 15.8, this is also 15.8. In square, all the sides are having the same length. So perimeter is adding all the sides. So when you will add 15.8 4 times, because we have 4 sides, so the perimeter would be 63.2 centimeter. In question number 9, they have told us that the volume of a box in the shape of a cube is 2197 centimeter cube. Find area of one side of the box. Now this is a box in the form of a cube, and we know that the cube has the same dimensions, mean this is x, the length, then we have got the width, which is also x, and then the height is also x. All three are same. Volume is given to 197 centimeter cube, and as you know that volume is obtained when you multiply length, that is x, with width, which is x, by height, which is x. So x into x is x square into x is x cube, and this is volume. Now volume is equal to 2197. Now take cube root on both sides. So cube root of 2197 is 13. Now if x is 13, that means all the three sides mean length is 13, width is 13, height is 13 in this cube. Now area of any one side means, suppose area of this side is x into x, that is 13 into 13, which is 169 centimeter square. Then in question number 10, you have to determine whether each of the following is a prime number or a composite number. Part A, 6, 6, 7. Now 6, 6, 7 have got the factors 23, 29, 1 and 6, 6, 7. So it is a composite number. Then in part B, you have got 6, 7, 7. Now 6, 7, 7 is a prime number because it has only two factors, 1 and 6, 6, 7. Then in part C, we have got 2021. Now 2021 has factors more than 2. 47 is a factor of 2021. I have done it over here, and 43 is also a factor of 2021. Moreover, 1 and 47, 1 and 2021 are also factors of 2021. So when you have more than two factors, now that is a composite number. So this is part C, 2021. If I have explained it, I pronounce it as 2021, then it's okay. So 2021 factors of 2021 are 1, 43, 47 and 2021. So having more than two factors of 2021, that's why it is composite. And the last part is 2027. Now this part is a prime number. We have only two factors of 2027, that is 1 and 2027. Now in question number 11, exercise 1a, they have told us that if suppose p and q are whole numbers, they are whole numbers p and q, and their multiplication is 37, then find the value of p plus q and explain your answer. Now if p and q are whole numbers, then if they are whole numbers, then p, suppose p is 1 and q is 37. I am explaining it over here. If p is 1, a whole number, and q is 37, then p into q, 1 into 37 is 37. P into q is 37, so p into q mean 1 into 37 is 37, while p plus q mean 1 plus 37 is 38. So 38 is your answer. While in question number 12, they have told us that if n is a whole number such that n into n plus 2, n plus 42 is a prime number, mean that this result is a prime number. This answer should be a prime number, whereas n here is a whole number. Find the prime number, and we have to explain the answer. Now this is the condition, and here in this case we are supposing n equal to 1, which is a whole number. So if n is 1, put 1 over here and 1 over here. So 1 plus 42 is 43 over here. 43 into 1 is 43. Now the result is 43, and as you know that 43 is a prime number, so hence n will be equal to 1. So in this lesson we have done exercise 1a of D1 7th edition. Keep watching and subscribe the channel if you haven't done it so. Thank you so much.